Hello learners, in the previous lecture we have studied different graphs in the different situations. Now today we have to make discussion about how to derive equations of motion by velocity time graph. These three equations of motion are very important. These three equations are given by Newton's here. Okay, and now just listen carefully. These three equations of motion are represented as, first equation here, V minus U is equal to 80 or V is equal to U plus 80. First equation of motion. Second is here, S is equal to UT plus half 80 square. Second equation of motion. Third is here, V square minus U square is equal to 2AS. This is third equation of motion. These three equations of motion have to derive from the velocity time graph. This is the main aim here. So the condition is here, when a body having uniformly accelerated motion travels in a straight line, the relationship between its initial velocity U, final velocity V, and uniform acceleration A and distance covered S in a given specific interval of time T, shows by these three equations, or you can say are called the equations of motion. Clear? Now here one by one we have to derive these three equations of motion. First of all we have to derive first equation of motion under velocity time graph. It is also written as V minus U is equal to 80 or V is equal to U plus 80. Sometime used to write the equation for velocity time relationship. Under VT graph. Clear? Okay, see, this is the graph here. First equation of motion, or V minus U is equal to 80. It is also written V is equal to U plus 80. Sometimes they used to ask, you have to derive the equation for velocity time relationship under velocity time graph. That means V minus U is equal to 80. We have to derive from the velocity time graph. Clear? Now see, this is horizontal axis, x-axis, and vertical axis, y-axis. In the horizontal axis we used to write the independent variable, that is time, in seconds, and in the vertical component we used to write velocity meter per second. Here consider the velocity time graph for a body that moves under uniform acceleration. the body has an initial velocity u at a point A. This is point A. Up to here, the body having initial velocity u. Clear? And then the body accelerates uniformly, and in time t it acquires the final velocity v at point B. Suppose that this one is point B and body acquires final velocity. Clear? To complete this figure, we have to draw a perpendicular. You used to say VC on time axis and perpendicular AD on BC. This is here velocity V, but as OA is equal to DC is equal to U, it means BD, this one is B, BD you may write as V minus U up to here. Okay, one more perpendicular BE on the vertical axis. Clear? Or you can say velocity axis. Is it clear? Okay, now it is evident from the velocity time graph that initial velocity at t is equal to 0. T is equal to 0 is equal to OA is equal to U. And the final velocity at time t. What is the value of final velocity here? BC is equal to V. Is it clear? Listen, the velocity time graph for a uniformly accelerated body is given by the straight line AB. This one is AB. Listen, the velocity time graph for a uniformly accelerated body is given by the straight line AB. So, the acceleration of body may be written as change in velocity upon time taken. Upon time taken. That is, A is equal to, what's the change in velocity? BD. And time taken is here, AD. BD having value BC minus DC. BC minus DC, you will get BD, V minus U, and AD, because this one is T here, OC is equal to T, OC is equal to AD is equal to T, so it may be written as T. Therefore, A is equal to B minus U upon T, or V minus U is equal to AT, V is equal to U plus AT. This is the first equation of motion. This is what? First equation of motion. Clear? You have to revise the first equation of motion, which we have derived under velocity time graph for a uniformly accelerated motion. Okay.